In section 6.8, we'll be discussing integration using long division and completing the square. Both of those things probably sound really scary and maybe things that you haven't done since Algebra 2, but there are some easy ways to know when you need to use these tools. So for example, when I am integrating a rational function whose numerator's degree is greater than or equal to its denominator's degree, so numerator's degree is greater than or equal to its denominator's degree, we have to use division. And so if this is just like x or x squared in the denominator, then I can just divide each term individually. But if there's an expression that has more than one term, I will have to use either long division or synthetic division. So for synthetic division, what I would do, I see that this works if I am dividing by a linear expression that has a leading coefficient of 1. And so I use this 0 of x minus 8, which is 8. And then I write my coefficients from my polynomial, 1, -7, -11, keeping in mind that if I'm missing a term here, like if this were x cubed and I didn't have an x squared, I'd have to put a 0 placeholder. And then when I do my division, I bring down the 1, multiply it by 8, that gives me 8. -7 plus 8 is 1. 1 times 8 is 8. That gives me a remainder of -3. That means that this, when I divide this, I would have x plus 1 minus 3 as a remainder. So I rewrite that as x plus 1. My remainder is minus 3 over x minus 8 dx. And now this looks like something I can actually integrate. So essentially we're just rewriting it first so that we can integrate it. My antiderivative of x is x squared over 2. Antiderivative of 1 is x. Antiderivative of minus 3 over x minus 8. This is technically a u substitution. But again, when I have a linear term here with a leading coefficient of 1, I don't actually have to formally write out my u substitution. This will just be minus 3 natural log absolute value of x minus 8. And then don't forget your plus c. For part B, we have 2x squared minus 17x minus 38 over 2x plus 3. I recognize that the degree of the numerator is higher than the degree of the denominator, so I know I will have to do division. Since I look and see when I'm dividing by 2x plus 3, that has a leading coefficient that is not 1, I will have to use long division. So my divisor is 2x plus 3. I'm dividing that into 2x squared minus 17x minus 38. So I'm looking for something that will cancel out this 2x squared when I multiply it by 2x plus 3. So that would be if I multiply this to 2x, look at your higher power term. If I multiply that by x, I would get this 2x squared. So I'm going to multiply by x, put that in line over where your x's are. This is going to help you keep track of everything. X times 2x plus 3 would be 2x squared plus 3x. But remember, when we're doing division, we're actually subtracting both of those terms. So we have 2x squared minus 2x squared is 0x squared. Negative 17x minus 3x is minus 20x. Minus 38 will just come down. And so now I'm looking, what do I multiply 2x plus 3 by to get negative 20x minus 38 or something close? So again, I'm paying attention to the higher power terms, 2x and negative 20x have to multiply by negative 10. So I would have negative 20x minus 30, but remember we're subtracting those. So I would get 0x, and then negative 38 minus negative 30 would be negative 8. That is my remainder. So when I rewrite my integral, it is x minus 10 minus 8 over 2x plus 3. So now I can take my antiderivative, x squared over 2 minus 10x. This is again the logarithm form. I see that I have a linear term here. Since the degree is not, the leading coefficient is not 1, all I'm going to need to do is divide by whatever the derivative is, which is what that coefficient is. So this is going to be minus 8 over 2 times natural log absolute value of 2x plus 3 plus c. which I can simplify to just minus 4. There's nothing wrong with writing out the u sub there. You can if you want, but it's best to get in the habit of not having to write it out. So what I would do is u equals 2x plus 3, du equals 2 dx, divide by 2. That's where this divide by 2 is coming from. And then I would have 1 over u or 8 over u that I'm integrating, which would be natural log absolute value of u. So that's where that came from. All right, for part C, we have the integral from 0 to 1 of 2x cubed minus x squared plus 2x plus 2 all over x squared plus 1. Again, I noticed that the degree of the numerator is higher than the degree of the denominator, so I know I'll have to use division. The term on the denominator is, or the expression on the denominator is quadratic, so I definitely have to use log division here. So my divisor is x squared plus 1, dividing that into 2x cubed minus x squared plus 2x plus 2. So I'm paying attention to this x squared plus 1. What would I multiply that by to get 2x cubed? And so I would multiply it by 2x. Again, remember, you want to, when you're writing this multiplication out, we're going to line that 2x up with where my x's are. So if I multiply that by 2x, I would have 2x cubed plus 2x. So I'm going to put that plus 2x underneath where my x's are. I'm subtracting those. So I'd have 0x cubed minus x squared minus 0 is minus x squared plus 0x here plus 2. And so then I still need to divide that by x squared plus 1. So what do I multiply x squared by to get negative x squared? That would be minus 1. So then I have negative x squared minus 1. Line up your terms there. We're subtracting. So these would all be 0. My remainder then is 2 minus negative 1. That's 3. And so when I rewrite this now, I can say that this will be the integral from 0 to 1 of 2x minus 1 plus 3 over x squared plus 1 dx. So I take my antiderivative first. Antiderivative of 2x is x squared. Antiderivative of minus 1 is minus x. Plus this 3 over x squared plus 1, you might be tempted to do natural log like we did in the last two examples. However, this is different. This is not natural log. This is actually the arctan problem. So when we see x squared plus another constant squared, that is arctan in your denominator. In order for this to be natural log, we would actually have to do a u substitution, and the derivative of x squared plus 1 would have to be up in my numerator. So this is just 3 arctan x. And then going from 0 to 1. I would say on these problems, most likely your integral over here will be either natural log, arctan, or some type of u sub is usually what's going to happen there. Antiderivative of x squared is x cubed, or sorry, we already did the antiderivative. I need to evaluate from 1 to 0. So I have 1 minus 1 plus 3 arctan of 1 minus 0 squared minus 0 plus 3 arctan of 0. On the AP test, you could leave your answer right there. We're going to go ahead and simplify it. 1 minus 1 is 0 plus 3. Arctan of 1 means when is tangent equal to 1? That is when sine and cosine are equal to each other at pi over 4. Minus 0. Arctan of 0 is also 0. That's when tangent is equal to 0. And so our final answer is just 3 pi over 4.